Welcome! Whether you're new to engineering or just curious about how things are made, you're in the right place. Today we're unlocking the secret language of manufacturing, GD&T, which stands for Geometric Dimensioning and Tolerancing. It's the foundation behind how products are built to precise standards. Think of GD&T as the universal rulebook that ensures every part, no matter where it's made in the world, fits and functions together perfectly, just like pieces of a puzzle. It's more than just simple measurements. GD&T defines exactly how straight, flat, or aligned a part must be, setting the bar for quality and precision. Without GD&T, parts might not fit together at all, leading to costly mistakes, wasted materials, and even product failures. This system uses a set of unique symbols to set clear, non-negotiable standards for every feature, making communication between designers and manufacturers crystal clear. Today, we'll focus on two essential concepts, flatness and straightness, core ideas that every engineer and technician should know. They might sound similar, but one controls the quality of a surface, while the other controls the accuracy of a line. Each plays a unique role in part performance. Understanding this difference is absolutely key to reading and interpreting any engineering drawing correctly. Let's break them down together. No engineering degree required. By the end, you'll see engineering drawings in a whole new light. First up, let's talk about flatness, a concept that goes far beyond just having a surface that feels smooth to the touch. Flatness means that every single point on a surface must lie between two perfectly parallel planes. Imagine a paper-thin gap, so thin that even the smallest bump or dip would matter. On engineering drawings, the flatness symbol looks like a parallelogram, and it's always followed by a number that shows the maximum allowed deviation from perfect flatness. To check flatness in practice, you place the part on a precision granite plate, then use a dial indicator to carefully measure the highest and lowest points across the surface. If the difference between those points is within the specified limit, the part passes the flatness test and is considered acceptable for use. Here's a real-world example. A car engine's cylinder head must be extremely flat to seal properly against the engine block. If it isn't, leaks can develop, leading to poor performance or even engine failure. So flatness isn't just a suggestion, it's a critical requirement for building reliable machines and ensuring parts fit and function as intended. That's the power of a simple geometric control, helping engineers create products that work flawlessly every single time. Now, let's delve into the concept of straightness. Straightness is a fundamental geometric control that governs a single line, either along a surface or the axis of a feature like a shaft. It ensures precision in engineering. The symbol representing straightness is a simple, unadorned straight line, yet it holds significant importance in design. For surfaces, straightness dictates that any line along the surface must remain within two parallel lines, ensuring uniformity and accuracy. For axes, the center line must fit snugly inside a tiny, perfect cylinder, maintaining alignment and balance. Consider a piston rod in a hydraulic cylinder. It must be impeccably straight, or it'll wear out seals, leading to leaks and inefficiencies. Surface straightness can be likened to the edge of a ruler. It must be perfectly straight to draw true, accurate lines. Axis straightness is crucial for components like a drive shaft, which must spin true to avoid destructive vibrations that can damage machinery. Straightness ensures that parts move, slide, or spin precisely as intended, maintaining smooth operation. Ultimately, it's all about ensuring function and reliability in every mechanical assembly. Let's compare. Flatness is a 3D control for entire surfaces. Think of a plate. Straightness is 2D, controlling a single line or axis. Think of a straight edge. Flatness uses two parallel planes as its tolerance zone. Straightness uses two lines or a cylinder. A surface can have straight lines but still fail flatness if it's twisted. Remember, flatness equals surface, straightness equals line. Flat plate, straight edge, it's a simple way to remember. These controls prevent assembly issues and ensure parts work together. Mastering this difference is crucial for anyone reading technical drawings. It's the foundation of precision engineering. Where do you see these in real life? Flatness is vital for surfaces that must seal or mate, like motor bases or vacuum chucks. Any warp can cause leaks or misalignment. Straightness is key for long, slender parts, like drive shafts or CNC guide rails. Even a slight bend can cause vibration, wear, or inaccuracy. These controls turn abstract rules into real-world reliability. Flatness ensures perfect mating. Straightness ensures smooth movement. Next time you see those symbols, you'll know exactly what's at stake. Now go build something awesome.